Hello all, I'm Siddharth Kaul and I welcome you to Edupedia World. In this video, we are going to take a look at expressions. Like most other programming languages, the MATLAB language provides mathematical expression. But unlike most programming languages, these expressions involve entire matrices. MATLAB does not require any type declaration or dimension statements while defining a variable. When MATLAB encounters a new variable name, it automatically creates the variable and allocates the appropriate amount of storage. If the variable already exists, MATLAB changes its content and if necessary allocates new storage space. For example, I'm going to define a variable my variable and assign it a value of 100. This creates a one by one matrix named my variable and stores the value of 100 in its single element. To view the matrix assigned to any variable, simply enter the variable name, my variable. So as you can see, 100 is displayed. Now, variable name consists of a letter followed by any number of letter, digits or underscores. Point to note is that MATLAB is case sensitive. It distinguishes between uppercase and lowercase letters. The capital A and small a are not the same variable. So if I type my variable with small a, I will see the value of 100. But if I type my variable with a capital A, I will see an error. Although variable names can be of any length, MATLAB uses only the first n characters of the name, where n is the number returned by the function nameLengthMax, and ignores the rest. Hence, it is important to make each variable name unique in the first n characters to enable MATLAB to distinguish variables. So to see what this n number can be on your machine, just type nameLengthMax and you will see the answer as 63. So basically you can have 63 number of characters to name your variable. Now MATLAB uses conventional decimal notation with an optional decimal point and leading plus or minus sign for numbers. Scientific notation uses the letter E to specify the power of 10 scale factor. Imaginary number uses either I or J as a suffix. Some examples of legal numbers are shown like 3, 5.46, 1i, minus 1.732j, 3e, 5i, 6.0789 e raised to power 12, things like that. MATLAB stores all numbers internally using the long format specified by the IEEE floating point standard. The floating point numbers have a finite precision of roughly 16 significant decimal digits and a finite range of roughly 10 to the power minus 308 to 10 to the power plus 308. So if you want to do a little reading on that, you can do an internet search and get the IEEE floating point standard. Now, numbers represented in double format have a maximum precision of 52 bits. Any double requiring more bits than 52 loses some sort of precision. For example, in the following code shows two unequal values to be equal because they are both truncated. So I write x as 98765432101234567 and y as similarly as 98765432101234566. So when I do an x equal to y, I get an answer as 1. Why? Because even though the numbers are different, the MATLAB has truncated the last two values and rounded off to the nearest value, hence making both of them equal. Integers also have a precision of 8-bit, 16-bit, 32-bit and 64-bit. So if I store the same numbers as a 64-bit integer, it will preserve its precision. So we will store x as unsigned integer 64 of 98765432101234567 and y similarly as unsigned integer 64 of 98765432101234566. So now if we do an x equal to y, we will get an answer as 0 because the precision has been maintained. MATLAB software stores the real and imaginary parts of a complex number. It handles the magnitude of the parts in different ways depending on the context it is used. For instance, the sort function sorts based on magnitude and resolves the ties by phase angle. So if I sort 2 plus 3i and 3 plus 2i, this is the sequence I get because the angle of 2 plus 3i is this and angle of 3 plus 2i is this. So as 3 plus 2i is a smaller angle, it precedes, and 2 plus 3i has a larger angle, it succeeds it. Thing to note for complex number is the equal to relational operator equal to requires both the real and imaginary parts to be equal. The other binary relation operators like greater than, less than, greater than equal to and less than equal to ignore the imaginary part of the number and considers only the real part. For matrix operation, MATLAB uses some familiar arithmetic operators and precedence rules. So as you can see, MATLAB also has addition, subtraction, multiplication, division, left division, power, complex conjugate transport, and specify evaluation order. So these are the precedence rule that MATLAB uses. Similarly, arithmetic operations on arrays are done by element. This means that addition and subtraction are same for arrays and matrices, but that multiplicative operators are different. MATLAB uses a dot or decimal point as part of notation for multiplicative array operation. So as you can see, we have the same operation for plus, for addition and subtraction. For but multiplication, we have an element by element multiplication. For that purpose, we use dot star. Similarly, division, we use dot division, and left division, we use dot left division. Similarly, for power, dot raised to power, and unconjugate array transpose at dot transpose. These are the array operation done on element by element. MATLAB provides a large number of standard elementary mathematical functions including absolute, square, expression, and sinusoidal. Taking the square root or algorithm of a negative number is not an error. The appropriate complex result is produced automatically. MATLAB also provides many more advanced mathematical functions including Bessel and gamma function. Most of these functions accept complex arguments. For a list of elementary mathematical functions, one can type help elementary func elfun and get elementary math functions like help on elementary math functions like trigonometry, exponential, complex, etc. For a list of more advanced mathematical and matrix function, one can type help specialized function as specfun and get specialized math functions such as Bessel function, factorial, etc. We can also get list of all elementary matrices and matrix manipulation functions by using elementary by typing help elmat. That will list all the elementary matrices and matrix manipulation functions. Some of the functions like square root and sinusoidal are built-in. Built-in functions are part of MATLAB code, so they are very efficient, but the computational details will not be easily accessible. Other functions are implemented in MATLAB programming language, so their computational details are accessible. There are some difference between built-in function and other function. For examples, for built-in function, you cannot see the code, and for other function, you can see the code and modify the code if you want. Several special functions provide some useful constant values, such as pi that provides the constant value of pi, I that provides the imaginary unit, j that is same as I, then we have absolute provides the floating point relative precision, then we have real minimum, we have real maximum, we have infinity, and we have not a number. Now point to note is infinity is generated by dividing a non-zero value by 0 or by evaluating well-defined mathematical functions that overflow, that is exceed the real max. Not a number nan is generated by trying to evaluate expression like 0 by 0 or infinity into infinity that do not have well-defined mathematical values. So any expression that you type that do not have a well-defined mathematical values, it will show as NaN. This concludes our video on expressions. In the next video, we are going to take a look at indexing. So till then, please subscribe and thanks for watching.